Hello. So today we're going to be looking at finding the area of polygons. And we're going to begin with a quadrilateral and special quadrilateral parallelograms, where opposite sides are parallel and opposite angles are congruent and adjacent angles are supplementary, meaning they add up to 180 degrees. So that's what a parallelogram is. It's a quadrilateral with opposite sides parallel. And a parallelogram, finding the area of a parallelogram is actually quite simple, because if you were to draw a diagonal, meaning from one vertex to another that it's not already connected to, you would see that you get two congruent triangles. And we know how to find the area of a triangle. It's 1/2 the base times the height. So if you have 1/2 the base times the height plus 1/2 the base times the height, you get just base times height. And so that's how you find the area of a parallelogram. Area of a parallelogram is just the base times the height. Now, there may be instances in which you may have to find the height using trigonometry, but the height will always be drawn straight down so that it forms a 90-degree angle with the extension of the other side. Or in this case, you could draw from here and draw straight up, and it would also form a 90-degree angle. Okay, so either one, you can always find it though, right? You can also split this if you would like, and then if you're given these two sides to say the angle between it, you could find the area of just one triangle and just double it. So those are the, essentially you're always just doing base times height, but because you know how to find the area of a triangle, you can split a parallelogram into half across the diagonal. And if you're given, say, the two sides and an angle, you can always find the area of the triangle and then double it in order to find the area of the whole parallelogram. Okay? Now, just to make things simple, what I like to do is to give you two examples. We'll do one where the base and height is given to us, and we'll do another in which case it's not, but we know enough information in order to find it. Okay, so let's do that. So, let's say we have a parallelogram. I'll redraw one. And let's say the height is 3 inches, and let's say that this side here is, it's also 3 inches. Ooh. Okay. Well, how would you find the area? Well, area would be the base. We don't know what the base is. Yes, we do. Because this is a parallelogram, if this is 3 inches, this also must be 3 inches. So we end up having 3 inches times the height, which in this case is also, when it was drawn, it's 3 inches. And so our area ends up being 9 square inches, or 9 inches squared. Okay, because remember, area, you must have a square unit. All right, that is actually honestly one of the most common mistakes that people make. They don't have square units for area. Okay, so there we have it. That's how you find the area of a parallelogram. Well, let's say something else was given to us. Let's say instead this angle is given to us is 50 degrees, and we are given that this is 2 inches and that this is, let's say, 7 inches. How will we find out what the area is? Well, we don't know base, we don't know height. We could find base by just moving this down here, but we still wouldn't know height. We have enough information to find the height, but we also can just do this. Split this right here, across the diagonal, and we're really looking at two congruent triangles that we know how to find the area of. So the area of this parallelogram is really just going to be 2 times 1/2 the product of the two sides times sine of the angle between it. You've seen that one before. So what we could do then is that will go away. So really we're just looking at the product of the two sides. So 7 times 2 times sine of the angle between it. So we end up with 14 times the sine of 50, which is approximately 10.725 inches squared, because they're inch times inches. Okay? So, knowing that this is a parallelogram, we were able to split this across a diagonal, forming two congruent triangles that we know how to find the area of. So 2 times the area of just one of the triangles, which in this case is going to be 1/2 the product of the two sides, times sine of the angle between them, because that's what's given to us. We were then able to substitute our values in here. The 2 and the 1/2 would cancel each other out. They would multiply to 1. We get 7 times 2, which is 10. And then we get sine of the angle, 50 degrees. And then, 7 times 2 is 14. And we get sine of the angle, 50 degrees. And then we substitute that into our input that into our calculator. We get 10.7. We get approximately 10.725 square inches. And that's how you can find the area of a parallelogram. Well, let's look at 2 other parallelograms that are very special. So you can pause if you need to. Okay. So let's say we have a parallelogram that happens to also be equiangular. What do you call that? That's right. We call that a rectangle. Okay. Let's say this side is 3, and let's say that this side is 4. We call it meters. 3 meters and 4 meters. So we have a rectangle with sides 3 and 4. How do we find the area of this? Oh, it's still base times height. That's right. So we would do area would be the base, 4 inches, times the height, 3 inches. Well, how do I know 3 inches is the height? Because remember, height is drawn from one vertex straight down to form 90-degree angles. Since it's a rectangle, it automatically is 90 degrees. So in this case, the area would be 12 square inches. Got to have that square units. All right. Many of you are probably saying, I've been doing that my whole life. I know how to do that. That's fine. That's great. But I wanted to show this so that you more solidify the fact that a rectangle is a parallelogram. And so you still have to be able to find an area the same way. And we do. We find it the exact same way. And it's something you're used to. So you can see something that you're used to and see where it comes from and how those two are solidified. Okay? All right. Well, if we were given a diagonal instead, we could use Pythagorean theorem, or we could use trigonometry in order to find out one of the other sides if it was missing. We won't look at that, and we won't look at that example, but that's something that you can do. You have the knowledge and experience with trigonometry in order to find one of the sides when given a hypotenuse in another side, or if you're given an angle in another side. Okay? All right. There's one more parallelogram example I want to look at, just to make sure we're all clear here. All right. So pause if you need to. Okay. All right. The last one is where we have a quadrilateral. That's a parallelogram, but it also happens to be regular, meaning all the sides are congruent and all the angles are congruent as well. What do you call that? A regular quadrilateral? That's right. Call it a square. Okay. So in cases we have a square, you may only be given the diagonal, or you may be only given one side length. So let's say this is 4 centimeters. Well, how would I find the area of the whole thing? I only know one side. That's right. If I know one side of a square, I know all of them because it's regular. So all the sides have to be congruent because it's a regular quadrilateral. So that means the side is also 4 centimeters. And so the area would be base times height would just be 4 centimeters times 4 centimeters. And so we end up with 16 square centimeters. Okay. That's why whenever you found the area of a square, maybe in the past they used to tell you just take one side and square it or multiply it times itself. That makes sense because we still have to do base times height, and the base and height would have to be congruent in this case because it's a square. All right. So that's how you find the area of parallelograms. If it was a quadrilateral that wasn't a parallelogram, how would we do that? If it was another type of polygon, like a pentagon or a hexagon, how would we do that? Let's say it was just a mixture of a convolution of all kinds of different polygons connected to each other. How would we do that? Well, let's see that next.